Hello and welcome everyone. My name is Dane Menke. I am the Digital Marketing Manager here at REGENESIS and Land Science. Before we get started, I have just a few administrative items to cover. Since we're trying to keep this under an hour, today's presentation will be conducted with the audience audio settings on mute. This will minimize unwanted background noise from the large number of participants joining us today. If the webinar or audio quality degrades, please try refreshing your browser. If that does not fix the issue, please disconnect and repeat the original login steps to rejoin the webcast. If you have a question, we encourage you to ask it using the question feature located on the webinar panel. We'll collect your questions and do our best to answer them at the end of the presentation. If we don't address your question within the time permitting, we'll make an effort to follow up with you after the webinar. We are recording this webinar, and a link to the recording will be emailed to you once it is available. In order to continue to sponsor events that are of value and worthy of your time, we will be sending out a brief survey following the webinar to get your feedback. Today's presentation will look at the fate and transport of PFAS as it relates to the Gustavus and Fairbanks Airport sites, including the use of PlumeStop at the Fairbanks International Airport. With that, I'd like to introduce our presenters for today. We are pleased to have with us Kristen Freiburger, Associate at Shannon Wilson. Kristen led Shannon Wilson in winning a 15-year contract with the state of Alaska to investigate, characterize, and remediate PFAS contamination near several Part 139 airports in Alaska. She and her team are currently assisting the state of Alaska with addressing legacy PFAS contamination originating from the international and rural airports throughout the state. Kristen's team is also responsible for community outreach, including public meetings and communication with stakeholders where necessary. We're also pleased to have with us today Maureen Dooley, Vice President Industrial Sector at REGENESIS. Maureen has over 25 years of experience in many aspects of the remediation industry, including project management, research and development, senior technical oversight, remedial design, and laboratory management. Her prior experience includes the completion of numerous treatability studies designed to evaluate the biodegradation of a wide range of chemical constituents that include chlorinated solvents, petroleum hydrocarbons, explosive aromatic hydrocarbons, and pesticides. In her current role at REGENESIS, she provides technical leadership for complex soil and groundwater remediation projects, including PFAS groundwater remediation treatment throughout North America, as well as remediation design, strategy, and business development in the northeastern US and eastern Canada. All right, so that concludes our introduction. So now I will hand things over to Kristen Freiburger to get us started.
All right, thank you. So today I will be discussing the fate and transport of PFAS at 2 of our Alaskan airports. As they mentioned, my name is Kristen Freiburger and I'm an associate with Shannon Wilson, where my specialty is in chemistry. I have the privilege of managing a group of environmental scientists in our Fairbanks office, and also overseeing the statewide PFAS contract with the state of Alaska, where we are investigating PFAS at several of the state-owned airports. And 2 of those sites will be in this presentation today. Most of my career, I have spent working on projects where private wells are impacted, and so there's a lot of PR in the projects that I work on. My portion of this talk will be about 30 minutes long, and I'll be discussing PFAS, their characteristics, our PlumeStop pilot study that we completed at the Fairbanks International Airport, and then also presenting the case study of the Gustavus Airport and how that relates to PFAS. Due to the overwhelming number of participants that signed up for this call, I decided to add in a section describing the basics of PFAS. So I'd like to dive into that just for 5 to 10 minutes here. PFAS is defined as per and polyfluoroalkyl substances. It is a class of 1,000 compounds or more, where it's broken into 2 different groups, perfluoroalkyls and polyfluoroalkyls, perfluoral being where this tail is fully fluorinated, as you see in here, or polyfluoroalkyls where the chain may not be fully fluorinated, and one of these fluorines would be something else. The talk that we're going to be giving today is focused on the perfluoroalkyl substances, though. PFAS compounds are highly soluble and persistent in the environment, and this is often referred to as forever chemicals in the media. And the regulatory environment in the United States is ever changing with respect to PFAS. PFAS and PFOA are the focus for most state regulations, and also federally, PFAS and PFOA are the only two compounds right now that have a lifetime health advisory. But I will note that many of these compounds are chemically similar due to this functional group on the end of the chain. And so additional regulations are anticipated to come out in the future. Toxicological data shows that these chemicals are harmful at parts per trillion levels. And throughout this presentation, I'll refer to that as nanograms per liter. And so why do we care? Because it's a widespread issue. And in America, 99% of us have detectable levels of PFAS in our bloodstream. There are several ways that PFAS compounds enter the environment. A landfill accumulating trash, such as fast food wrappers or carpet that contains PFAS is one way, or water treatment plants that force precursors to transform into their fully fluorinated end product is another example. But for the purpose of this presentation, I'm going to be focusing on AFFF use at Part 139 airports. AFFF and historical AFFF contains a variety of PFAS, more than just PFAS and PFOA, but again, the focus tends to be on these two compounds. AFFF has been widely used at airports due to a requirement by the FAA for them to train at least on an annual basis. And oftentimes these trainings were conducted on the ground surface. This requirement was lifted in 2019. However, an alternative foam has not yet been approved for use at airports. Now, I'm a chemist, so of course we have to take a minute to talk about the chemistry of PFAS. And like I said, I'm focusing on the perfluoroalkyl substances for this presentation. So here you see a fully fluorinated, what's referred to as the tail. And so that is a hydro and lipophilic fluorinated chain, like I said, referred to as the tail. And also the hydrophilic polar functional group that's often referred to as the head. The interaction of these two parts of the compound force partitioning to occur at various environmental interfaces. And it's also what makes these compounds excellent at suppressing fires based on how they interact with one another. So you can see that they can form layers that allow them to smother fires. I'm not going to get too far into the chemistry, but I did want to take a moment to say that. The focus of our site investigations is to locate areas where AFFF has been directly discharged on the site. That is not always an easy thing to do since historical use is not well documented and field screening methods do not yet exist. So oftentimes what we get is old photos that may or may not benefit you in understanding where it is on the site. For example, I've received this photo for our Gustavus site. It's great because it shows us that AFFF was used to put out a petroleum fire. However, where it is on the site is harder to tell because the trees are much larger and there's a lot more vegetation in the area now. Once PFAS or an AFFF has been sprayed on the ground, it can then infiltrate to the groundwater through the pathway you see here. Or it can be carried off of the site or to other parts of the site via the dust moving throughout the air. Contaminated groundwater through infiltration from either a AFFF source or maybe a surface water body or another source can move contaminants through the subsurface to other surface water bodies. So here you can see the interaction of groundwater with another surface water body, and through the process of diffusion, contaminants can then get into this other surface water body. Surface water can also become contaminated through runoff from contaminated soils or even asphalt. So you can see that pathway here where the foam is sprayed and then runoff from a precipitation event can lead to a surface water body, or as well over here. Groundwater is important to investigate as it may be a direct pathway for human consumption, shown here. And surface water is very important to investigate as it may carry the contaminant great distances from the source. Since these compounds are highly soluble and persistent, you may run into large plumes that are quite expensive to remediate. So keeping PFAS from reaching water bodies should be of utmost concern. As a side note, I wanted to throw it out that one piece of information we have noticed in our data sets is that some of the shorter chains travel faster and are often found at the leading edges of the plume. For example, PFHXS, while not regulated in many areas, might be good for you to look for, as it could be an indicator as to where the other PFAS molecules will eventually move. Larger chains tend to be somewhat retarded in the subsurface, especially in areas with high concentrations of organics. The chain of the heavier compounds may partition to the organic material while it's moving through the subsurface. This portion of my talk regarding the Fairbanks International Airport is mostly going to focus on our PlumeStop study that we've completed at the site and is not a representation of all the samples that we have collected there. I wanted to show where Fairbanks, Alaska is. We're just below the Arctic Circle here in the heart of Alaska. This project began the same way so many of our projects do. Our client detected PFAS above regulatory limits in some on-site monitoring wells. And since the groundwater was known to move towards residences with private wells, the airport responded immediately and authorized us to conduct a well search. In Alaska, not everyone is connected to city water despite being in city areas. This is one area of Fairbanks where city water was not yet available. This map shows the results where concentrations that were above PFAS and PFOA combined of 65 parts per trillion are shown in red, and either non-detect or below 65 parts per trillion are shown in green. The red properties are considered affected properties and have since been connected to a municipal water line. This map also shows monitoring well 1903-20, which is where the PlumeStop study occurred. The purpose of our PlumeStop study was to evaluate the effectiveness of the material in our local aquifer. Funding for this project was a group effort between Shannon Wilson, REGENESIS, Geotech, and the state of Alaska. And we really liked the idea of using an in situ method that could provide a barrier to prevent contamination from spreading to private properties. PlumeStop is a colloidal activated charcoal that's injected into the subsurface and acts as a filter to remove contaminants from the groundwater. Our study was originally designed for PlumeStop to sequester PFAS, PFOA, PFHPA, PFHXS, and PFNA. Several other analytes were also evaluated and reported per our regulatory obligations. However, due to the regulations at the time the study was designed, these analytes were our focus. We installed a 20-foot monitoring well within a known PFAS impacted area, and several samples were collected before and after to evaluate the dose response of these 5 PFAS compounds. Prior to PlumeStop injection, we collected site-specific data as part of the design verification testing process. We collected soils and logged the description and type of material we found, as well as submitted those samples for grain size analysis. We also installed a passive flux meter in the well for approximately 2 weeks so that we could measure the Darcy velocity and also PFAS mass flux through the well screen. We relied on regional groundwater velocity and gradient information as well for this study, although that proved to be problematic as the local aquifer was much faster than the regional information suggested, and it required additional product to be injected. Sampling conducted prior to injection detected 9 different PFAS compounds, and I have listed the top 6 here. The top 3, PFAS, PFOA, and HXS, were part of the study and specifically what we were looking at, but again, we collected information on other PFAS so that we could also look at the effectiveness on PlumeStop on those analytes as well. PlumeStop injection occurred in late fall of 2019, although to those of you not in Alaska, that probably looks like winter. I will note that REGENESIS worked with the drilling contractor to find a method and a pump that we could use and adjusted on the fly so that we could find additional pumps that would be useful in injecting large volumes of PlumeStop in frozen conditions. The quick aquifer had made the parking of the PlumeStop difficult, and so we needed to find different types of pumps that could handle the speed of the aquifer. During injection, several controls were in place. Changes to the aquifer were measured using temporary wells installed near the injection site. You can see the study well in the background here, and then the temporary well that we're observing throughout the injection process. Subsurface sample cores were also collected to observe PlumeStop staining. Here you can see the PlumeStop staining. And this is one of the biggest indicators that we had that PlumeStop needed to be injected at a more rapid pace in order to combat that speed of the aquifer and park the PlumeStop within the entire length of that well screen. The aquifer in this area is known to fluctuate due to it being situated between two rivers. We have the Chino River being shown here. If you remember that previous map, there is a large river right through here that's called the Tanana River. So for that reason, our aquifer does fluctuate in direction. So PlumeStop was injected surrounding the well, as you can see here. These are the injection points, although there was more focus placed on the eastern portion that is closer to the site and the contamination. Approximately 8,500 gallons of PlumeStop was injected in these 20 points here. And this map also shows the location of the temporary wells. Immediately following the injection, we began collecting samples. The first set of samples were collected in December of 2019. The sample was sent to REGENESIS to run through their centrifuge, because as you can see, there was PlumeStop in that sample. And the commercial lab did not have a centrifuge option available. Analysis in that initial sample showed PFAS at a J flag level below the reporting limit. However, no other PFAS were detected in that sample. Our intention was to monitor the well for 1 year on a quarterly basis following the injection. However, samples that were to be collected in March 2020 and June 2020 still contained a high concentration of PlumeStop, and we decided to save our analytical budget for samples to be collected later. Also, laboratories weren't necessarily available in March 2020 since that was the start of the pandemic. We checked the well regularly during this time though, to visually inspect the concentrations of the PlumeStop. And in September of 2020, we officially began the 1 year of monitoring. Samples were submitted to Eurofins, Test America, and Sacramento for the analysis of the PFAS. And this slide here shows the results of the overall study. These first two columns show the baseline samples that we collected. You can see that PFAS and PFOA exceeded the regulatory limits at the time. We also had high levels of HXS, and we also saw PFHPA, although PFNA that this was designed for was not detected at that time. This column here shows the very first sample that we collected after the injection. Like I said, there is PFAS at a low level that was detected in that sample, but we did have a significant amount of activated carbon still in that sample at about 2,500 milligrams per liter. Those March and June samples that I was talking about, the only thing we analyzed those for was the PlumeStop concentration, but by September 2020, we were able to start collecting the follow-up samples. And what we saw in that first sample the first quarterly sample in September, is that we did still have some low-level PFAS in there, but we also saw that PFBA and PFPEA had started to break through. And then these next three columns show the additional samples that were collected on a quarterly basis. And in the last sample collected in June of 2021, we found that the 5 compounds that this product was designed for, it were fully sequestered, and PFNA still was not detected. But we did also see that PFBA, PFBS, and PFPEA did have detectable levels, and the PFBA was back at its beginning concentration. So to follow up this study, we're looking to monitor this location on an annual basis so that we can continue evaluating the absorption capacity of the PlumeStop. We're also looking to see how this technology may be beneficial at other parts of the site or at other sites within Alaska. And one of those sites is Gustavus Airport. I wanted to put in this part of the talk regarding the Gustavus Airport because there are several different types of samples that we've collected at this airport. And in case there are any of you on this call that would like to add this information to further your research on PFAS fate and transport, I would like to present it, and feel free to reach out to me and ask for that information so that we can get that to you. One thing I will note is that this community is highly involved, and they also have been collecting their own samples, such as various biota samples and blood samples, and I could get you in contact with them as well. Gustavus, Alaska is located in Southeast Alaska near Glacier Bay National Park and Juneau. So while it's in the same state, I will just point out that our state is very large, and there are 2 very different types of environments that we're working in compared to the Fairbanks Airport. The Gustavus project began with DOT collecting water samples from 2 community wells in the area. This well here is noted as the airport terminal well. It serves the Alaska Airline building and the Alaska Seaplanes building at the airport. And also this well here is the National Park Service well, and it serves the school in town. Both of these wells showed detectable levels of PFAS, so we mobilized to the site within 2 weeks to start our private well sampling. Due to the known use of AFFF in this area here, this was the most recent area where training occurred. And then also just off the map, there is an old burn pit in this area. So due to the use in these 2 areas and that we knew that the groundwater flowed to the south, our initial well search began in this area here directly to the south. But at one of the public meetings that we held, a local GIS specialist with the National Park Service shared her local understanding of how water flows through and from the airport. And so she noted that we should collect some samples on the west side here. And so we did. And when those results came back, it showed that that area was of more concern. And we quickly mobilized to continue collecting samples on the west side of the airport here. And we continued until the concentrations in the samples were below the action limit at that time. At that time, the action limit was for 5 different PFAS compounds compared to 65 parts per trillion. So on the edge where you see these green, the sampling stopped there because we no longer detected concentrations above that action level. Widespread residential sampling can provide a dense understanding of PFAS in the area and how it is moving through the groundwater. In Gustavus, people have wells that are about the same depth, about 25 feet below the ground surface. But in other areas of our state, when we conduct these well searches, it does allow us the opportunity to collect samples at various depths. A neighbor may have a 100-foot well, whereas the other neighbor may have a 40-foot well, and you may find very different levels of PFAS in those wells. Although in this particular community, everyone has about the same depth of well, and so it provides a clear picture of where the contamination has moved to. One thing I wanted to point out is when you are using private wells, it's a fairly dense set of data, and you may run into other sources. So there's this sample here that kind of jumps out as why is it red in the middle of green? This is a site where the city of Gustavus had responded to a brush fire at this property and used AFFF to put out that fire. And to this day, this is actually the highest concentration that I have seen in a private well. Interestingly, it doesn't appear to move too far from the site. Surface water and sediment samples collected in Gustavus provide us information on where PFAS is moving from the former AFFF areas. And due to local flooding that occurs from the gravel pits to the north, here's the gravel pits, DOT is currently looking to complete a ditching project where the various ditches will be dredged to allow more volume for these floodwaters to move through. However, that's been a problem in that the samples we have collected have shown that not only is the water contaminated, but the sediments are as well. This particular location here is a slough. It's referred to by the community as the duck pond, and it is one of the higher levels of contamination that we find in surface water in Gustavus. And then obviously the sediment samples collected along there also showed that PFAS was present. And even though PFAS is present in the sediments below the current cleanup levels, it does still show detectable levels, and so therefore proper handling of that material would be needed in order to prevent spreading contamination to new areas. This duck pond here that I referred to is known to infiltrate and flow to the properties to the southwest. If you remember from that previous map, this is the area in which the private wells were mostly affected by PFAS contamination. And that is why the community is interested in using PlumeStop to inject along Wilson Road here to provide a barrier from this duck pond area that then infiltrates and moves towards their residential area. And they've already started working on some of that design verification testing to provide that information. I will just note that whenever you are collecting surface water samples, you may need to walk out pretty far. So do make sure that your boots are PFAS free and that you have a hand auger readily available in order to collect the soils. During our most recent round of site characterization activities, which was in October of 2021, we installed several more monitoring wells, and the results are presented here. Please note that this is a draft map and the results are not publicly available, although DOT has authorized that I can use it in this presentation. This map shows any PFAS detected in a well and is not necessarily just limited to PFOS and PFOA like the previous maps. And one other thing we stumbled across with these monitoring wells is yet another source of PFAS contamination. This well here, Maureen well 2-20, was first installed in 2019. At that time, there were barely detectable levels of PFAS in the monitoring well. However, a year later during our monitoring, we saw PFAS concentrations jump and continue to rise in each subsequent sampling event. PFAS is not detected in the monitoring well in the same area, which is just 10 feet deeper, and that suggests that a surface release has happened. Our DEC is currently investigating this site. And I'll just note that PFAS forensics is a whole nother topic and not part of my talk here, but if this is an area of expertise for you, I would love to talk to you, so please reach out. Our first round of surface soil samples at the site were spread throughout the site, and this happened in fall of 2019. Given there are no field screening methods, our samples were centered around where AFFF is known to have been used. And we also added in some random samples along the runway, as you see here, with all of these various green dots. And one sample did show us a new area of contamination. Also in fall of 2019, the community of Gustavus worked on and produced a report where they had conducted interviews with several former and current firefighters. And this report documented not only the areas of AFFF use that we knew about, but also some new ones. And so our soil sampling that happened in 2021 was refined based on the information in this report. Again, this is a draft report. It's not yet publicly available, but will be soon. But you can see that some of these new areas we hadn't previously found, we were able to document the concentrations. This particular area here is one of the higher areas of contamination that we weren't previously aware AFFF had been sprayed on, but the community report really helped us to hone in on that particular area. As well as outside of the DOT building, we see concentrations in the surface that we hadn't necessarily been able to locate previously. We also focused our 2021 efforts on collecting samples at depth so we can understand the extent of the surface contamination, but I don't have those results on here. Another area where the community's AFFF report helped guide our project was in understanding how asphalt might be impacted by AFFF use. So prior to a resurfacing project that happened this past summer in Gustavus, the DEC collected asphalt samples from various areas throughout the runways, and they are depicted here. Any samples where PFAS was not detected are shown in green. If it was detected but below the regulatory limits is shown in yellow, and above the regulatory limits is shown in red. Red material was segregated on a liner over in this area. This area was selected because it is where the old burn pit is located and known to be an impacted area. Yellow material went here and green material went here. As part of helping the state understand how asphalt relates to the current cleanup levels, which are soil cleanup levels, and what that may mean as far as leaching from asphalt, we collected samples using the synthetic leaching, I'm sorry, did I say that correctly? Synthetic precipitation leaching procedure, also known as SPLP. And those results are here. These are the PFAS samples. I'm going to focus in on PFOS. You see that PFOS was detected in the asphalt as high as 1.5. And how that related to the leaching is, here's the SPLP results. That relates to the leaching in that 1.5 parts per billion in asphalt came up at about 22 parts per trillion leachable PFAS in the SPLP sample. The last thing I wanted to present on is our asphalt core sampling. I'll just note this is a very limited data set, but again, I wanted to provide this information in case anyone would like to add it to their current data set. We collected this sample using the coring method that the contractor had on site already. So water was used to drill this core. And so for that reason, we took great care to avoid collecting any sample from the edges of this core. This table here shows the results that we found in asphalt. The concentrations at the surface were quite high, not surprising based on the location in which we had collected these cores from, but 1.5 inches down, we still found significant levels, although much lower than what we found at the surface. And then 2.5 inches down, we did not find detectable PFAS in the one. We did find it in the second sample, but notably the smaller compounds seem to still be detectable in that 2.5 foot or 2.5 inch level. And then we collected a sample from near the bottom of that asphalt core, and we saw the PFAS and other compounds jump back up. And like I said, this is a very limited data set. Our working theory right now is that previously when the runway had been resurfaced, that milled material was milled and then left in place and used as the base for the new runway that we had collected this sample from. So on the screen, you have my contact information. And with that, I'll go ahead and hand things off to Maureen Dooley with REGENESIS.
Thank you, Kristen. That was really a great presentation. And I had the opportunity to see your presentation on Fairbanks a few years ago at the Airport Executive Association meeting. And I think that was when you had just completed the PlumeStop application. And I was really delighted to hear that you were able to share this information and experience as part of our webinar series. I think these sites present, a number of challenges, and I think we can all appreciate and learn, from your experiences. And as I was thinking about this presentation, it comes to mind, the many challenges that these airport sites have, and they can be a commercial site or a DoD facility. And, just for starters, just the sensitive infrastructure we're working around. Access to contamination and understanding where the contamination is and the sources. I think Kristen really highlighted that point with some of this really interesting data that she collected associated with the asphalt. But airport operations, if you're conducting work at a site, you have to really keep that in mind. I think another important thing to consider, and again, Kristen highlighted this, is understanding what the receptors are, your ecological receptors, or also, the abutters or the folks that in the community that are impacted by this contamination that may be moving off site. So with REGENESIS, we've worked on airport sites for a number of years, covering a range of contaminants. It, could be, hydrocarbons, fuel sources, chlorinated solvents, and then, more recently, our PFAS contamination. I'm, looking at some of the more standard contaminants like petroleum hydrocarbons. In the last year, we successfully applied Petrofix to address petroleum hydrocarbon contamination. And Petrofix is our colloidal activated carbon formulation that is specific for petroleum hydrocarbons. But with this presentation, we're really focused on this emerging contaminants in PFAS. So just really to give folks an update on where REGENESIS is in working with PlumeStop applications to address PFAS. To date, we have 26 applications in different spots, covering the globe. And if you look at the US, many of these applications are focused in states that have, a more robust regulatory environment when it's concerned or focused on PFAS. As far as other sites that we're looking at, we probably have at least another 140 or so that are in different stages of evaluation and design development. The types of sites that we're typically looking at for PFAS remediation are, of course, our airport sites, as we just saw in our presentation today, DoD facilities, but we probably have looked primarily or worked primarily on industrial manufacturing facilities. And of note, we had a site that was granted a certificate of completion by New York State under their Brownfield program this past December. And this was a site where PlumeStop was used to address PFAS contamination. We've been working with PlumeStop and applications to address, a range of contamination. It's got to be over, 7+ years now. And with the PFAS, a little less than that. But over this time frame, we've gained a lot of experience, and we're at a point where we have a lot of confidence in our ability to develop a design that can allow you to reach these target cleanup levels, which can be very low, and maintain them for an extended period of time. So what REGENESIS has developed is a warranty program that we refer to as PlumeShield. So PlumeShield, what's PlumeShield? PlumeShield is our warranty program. So if you have a site where you have PFAS contamination and you wanted to consider something like this, what you would do is provide REGENESIS with the site information, and we'll evaluate your site to see if it's feasible. And we, at that point, can provide you with a cost proposal. If this is something that we find acceptable, what REGENESIS will do is move into a commissioning phase. And what this involves is conducting some design verification activities, confirming the feasibility and the design. And the design verification is very similar to some of the data that Kristen presented. And we see how important collecting that data can be to make sure we have a design that will allow us to achieve these targets and these goals. I think one thing that's really important to understand that the payment schedules are designed to be associated with meeting performance criteria. So we can offer up to a standard 10-year warranty up to 30 years. So, the benefit here is we're looking at a technology that can be very cost effective, particularly when compared to groundwater extraction systems. There's no financial risk. It's also important to understand that there's no waste generated when using PlumeStop to address PFAS contamination, and we have this warranty. And it's also very sustainable, as we know that sustainability is another factor that's often considered when looking at different remediation approaches. With PFAS remediation, there's constantly new developments that are taking place. And what I'd like to try to point out are some of the new papers that we've come across and to provide those as references. So we have QR codes for a couple of different papers. And if you're not fast enough with your phone to pick these up, we will send the recording out so you can see this, once it gets sent out. But anyway, the airport business article mentions Kristen and focuses on issues with PFAS around airports. Another really interesting article is one with SAME, where you're looking at PFAS and associated issues with DOD. One paper that was really interesting that just came out in Remediation Journal is one by Dr. Newell, where he talks about monitored natural attenuation as an approach for PFAS. So it's a bit of a roadmap and ways to analyze sites for monitored natural attenuation, and I think it's one that's really interesting. REGENESIS also has resources on its webpage that you can also refer to try to keep up to date on some of the latest things that are happening in this area. So with that, I would like to thank Kristen again for a wonderful presentation, and we would be most happy to take any questions.
Thank you, Maureen. That concludes the formal section of our presentation. So at this point, we'd like to shift into the question and answer portion of the webcast. Before we do this, just a couple quick reminders. First, we will be sending out a brief survey after the webinar. We really appreciate your feedback, so please let us know how we did. Also, you will receive an email with a recording as soon as it is available. All right, so let's circle back to the questions. First question is for Kristen, and the question is, has a drinking water solution been provided to the properties with PFAS contamination in Gustavus, Alaska?
Oh, good question. Yes, affected locations, which are currently defined as any location where the LHA, so PFAS and PFOA summed, is greater than the LHA, so 70 parts per trillion. They have been provided bottled water, and that will continue until a long-term solution is provided. There are some locations that have been that their long-term solution has been installed. And we are looking at rain catchment cisterns in Gustavus as a way of providing alternative water.
All right, thank you, Kristen. So here's another question. This one is from Maureen. Maureen, the question is, does the application of PlumeStop change groundwater flow rates?
Oh, that's an interesting question. The answer is no. The PlumeStop itself, the colloidal activated carbon, is a very small particle size. So this is applied and it will end up coating the soil in something like maybe like a 10 micron coating. So there isn't any change to hydraulic conductivity. And I know there've been some work or some studies have been published. Rick McGregor is one person that comes to mind that's published on that. And I think we have some of the references for that, showing some of the data that were collected after an application and that there wasn't any change in hydraulic conductivity.
Okay, thank you, Maureen. So there is another question here. This one is for Kristen, and it is, what do you think is the best use of the PlumeStop technology?
So I think there's a wide range of applications for PlumeStop. We talked about the one where you could inject it to prevent it from moving to receptors. But when I start thinking about how do I want to use this at sites on a regular basis, I think one of the most ideal situations, in my opinion, is that you would remediate, or I'm sorry, excavate some of these source areas, and then PlumeStop could be injected down gradient to capture any of that residual contamination that might remain after you've excavated the soils.
All right, thank you, Kristen. So Maureen, here is another question for you. The question is, will more than one application of PlumeStop be required for a barrier to last 10 to 30 years?
Oh, thank you. It's kind of interesting. It almost fits. There's part of this answer may fit in with what Kristen just said, but the answer, it depends. So, this gets into how long is a barrier going to last? Do I have to reapply? And what's going to be really important is for us to understand the contaminant flux and concentrations that are coming into the barrier. And many barriers that we have installed, our modeling suggests that they're going to be good for decades. But one thing that Kristen just brought up is the importance of understanding the source. Are we addressing the source? Because if you have a barrier and if you're able to address the source, that means over time there's going to be less flux coming into the barrier. But what we'll do is we'll look at each site individually. We can run models and we'll get an estimate of what's required. So the answer is it depends.
Okay, thank you, Maureen. So here's another question for Kristen. And Kristen, this is regarding the slide where you show the private well results in Gustavus. A few questions regarding that slide. How long ago was the AFFF applied at the brush fire? And do you anticipate it will move? And also, are there homes near there being monitored?
Yeah, so the AFFF in that area was applied many years ago. I believe it was 7, if I'm remembering correctly right now. And DEC has taken this site on as one that they are monitoring. And so they are regularly collecting samples from mine wells and the private wells surrounding there. And interestingly, we do not see much movement of PFAS from that site. It's likely due to the high organic content of the surface and the subsurface soils in that area, but it is one that DEC is continuing to monitor.
All right, thank you, Kristen. So here is another question for Maureen. Maureen, the question is, can PlumeStop be used to treat PFAS contaminants if other contaminants such as petroleum hydrocarbons are also present?
Yeah, the answer to that is yes, absolutely. What we found in probably, a great number of our sites is there's been some co-contamination, be it chlorinated solvents or petroleum hydrocarbons. For chlorinated solvents, we've often co-applied ZVI to address those. Or with petroleum hydrocarbons, we have, different options for something like, adding ORC or sulfate. But it does bring up the point that it's really important to understand if there are any other co-contaminants or anything else in the groundwater that may may interact with the colloidal carbon or the PlumeStop, so we can take that into account when developing our design.
Okay, thanks, Maureen. So here's another question for Kristen. And Kristen, the question is for the site where you used PlumeStop. The smaller PFAS compounds, specifically PFBS, appear to have broken through. Is there a way to capture these analytes using this technology?
Yeah, so PFBS and other similar short chain compounds can be sorbed using PlumeStop. They're just much less sorptive than, say, PFAS. So if a PFAS comes through, it's going to kick off that PFBS and take the site. And since most regulating bodies don't seem to be concerned with PFBS at this point, that obviously wasn't a focus of our investigation. But if you're working at a site where PlumeStop would be needed to sorb a PFBS, REGENESIS can work with their modeling to determine how much product would be needed in order to sequester those smaller compounds too. So the answer is yes, you may need more product, and it would be worth working with REGENESIS just to make sure that the volume that you may be required would still be cost effective.
Okay, thank you, Kristen. So we have another question here for Maureen. Maureen, the question is, there was a paper recently published by Dr. Newell that describes monitored natural attenuation as a potential remedy for PFAS. So the question is, can PlumeStop be used in conjunction with MNA?
Oh, that's interesting. And I mentioned, I mentioned that paper at the end here is something new that's come out. And in a bit, it kind of takes me back a little bit to when monitored natural attenuation was first being brought up to address petroleum, hydrocarbons, and chlorinated solvents. And I think what's interesting here is it's really just re-looking at these sites is part of, controlling exposures and controlling risk. And so, does PlumeStop fit into this? And I think absolutely yes, because if you start, it's written in the paper, in this paper, it gets into, I think, this roadmap on how one might do an investigation. And with the nature of this contaminant and how it can move and it's not breaking down, that the ability to enhance these natural attenuation mechanisms like sorption by applying reagent like PlumeStop to increase sorption, you can ultimately get to a point where you have a plume that's going to be stable or in decline, and that fits with that whole monitored natural attenuation program where you can where the plume ultimately ends up getting cut off, so it's not impacting these receptors. So I would I would just say again, I'd refer people to that paper, take a look, and I think the application of PlumeStop could be something that certainly goes right along with that.
Okay, thank you very much, Maureen. So that is going to be the end of our chat questions. If we did not get to your question, someone will make an effort to follow up with you. If you'd like to learn more about services from Shannon Wilson, you can visit shannonwilson.com. If you would like to learn more about remediation solutions from REGENESIS, please visit regenesis.com. Thanks again very much to Kristen Freiburger and to Maureen Dooley, and thanks to everyone who could join us. Have a great day.